everybody, today we're going to talk about initial velocity and finding the constant of integration. The acceleration due to gravity is about 32.17 feet per second squared. As a function, we could write that as a of t is equal to negative 32.17. When we discussed derivatives, we found that the derivative of velocity is acceleration. That means if we integrate the acceleration, we'll find the velocity function. We can write that as v of t is equal to the integral of negative 32.17 dt. That integrates to negative 32.17t plus c. So if you're wondering what is c, c is the constant of integration. When finding v of t, c would be the initial velocity of the object. Consider this, say we're standing on the top of a bridge and we throw a ball down to the ground below. How long the ball takes to hit the ground will depend on how high the bridge is and how fast we throw the ball. There should be a big difference in the time it takes to hit the ground based on the initial velocity of the ball. For example, if a Major League Baseball pitcher were to throw a ball at 100 miles an hour, then the velocity function would be v of t is negative 32.17t plus c. To find c, we are going to convert 100 miles per hour over into feet per second because our acceleration was given in feet per second squared. To change hours into seconds, we first multiply by 1 hour having 60 minutes, then every minute will have 60 seconds. Then to go from miles to feet, we're going to multiply by 5,280 feet in a mile. This says our initial velocity was 146.67 feet per second. Putting this into our function, we have v of 0 is 146.67, then 146.67 is equal to negative 32.17 times 0 plus c, which essentially says 146.67 is c. Our velocity function is negative 32.17t plus 146.67. If a Little League Baseball pitcher were to throw a ball at 40 miles per hour, then we can find the velocity function by first converting 40 miles per hour over into feet per second. This time we get 58.67 feet per second. That becomes v of 0, which tells us that our constant of integration is 58.67. The difference in velocities comes from the initial velocity of the pitcher. This difference shows the importance of the constant of integration when solving antiderivative problems. This also shows us how gravity slows down the ball as time elapses.